We are asked to determine whether each of these sequences converges or diverges. For the first sequence, we can apply the limit of sequence theorem. So let's determine the limit of this sequence as a function of x. As x goes to infinity, the numerator clearly goes to infinity, and so does the denominator. This is an indeterminate form. To find this limit, we factor out the highest degree of x in both the numerator and the denominator. Since x goes to infinity, x must be positive, and so the square root of x squared is equal to x. Let's rewrite this. Now we can take the limit. First of all, the term x over x is just simply equal to 1, and 1 over x squared goes to 0 as x goes to infinity. This means the limit evaluates to the square root of 7. And so by our limit of sequence theorem, this sequence converges. We try the same theorem for the second sequence. As x goes to infinity, we have infinity minus infinity in the numerator and infinity plus infinity in the denominator. Clearly, the numerator is an indeterminate form. To find this limit, we divide all terms by 5 to the x. Now we can take the limit. And since 3 over 5 is smaller than 1, larger than 0, 3 over 5 to the power of x when x goes to infinity must go to 0. So our limit is simply -1. Once again, we have a real number for our limit, so this sequence converges. For the third sequence, taking the limit is not so easy. Let's instead use a graph and determine what the sequence looks like. We have chosen our graph very carefully by choosing tick marks of pi over 4. So when n is equal to 1, the first term of the sequence is cosine pi over 4, which has this value on the graph. When n is equal to 2, the second term is cosine of pi over 2, which is 0 right here. When n is equal to 3, the third term of the sequence is cosine of 3 pi over 4, which is here on the graph. And we continue in this process in steps of pi over 4, and so on. And so what we've noticed, since the cosine is periodic, these values will repeat and never converge to a specific value. Therefore, this last sequence diverges.